In this note, we will add some background on the enactment of the grounding of the ever given, and this is mainly a demonstration on the use of the program qtVlm and its many powerful features for this type of analysis and for actual navigation underway. Very popular program for real navigation. Also for training, it's one of the top programs in the world for training exercises. And so let's start out. We have to show our simulation method, and what this program can do is when you're running your real vessel, your actual vessel, you can export all the NEMA sentences that your instruments are providing. You can export them and save them in a file, and then export that and reload it. And that data, when you rerun it or use it and analyze it, you can create better performance diagrams of polar diagrams for your sailboat. That's one reason for doing it. Or study a past race, things like that. We can make a track of it. I want to show some of that, some of the power of that. But it's very, very useful for training and for this type of exercise. So we save real data from your actual voyage or a race and then replay it. Or in this case, we actually are simulating the data. We're making the data. And I'm showing here how we do that. So here is AIS data, which is publicly available. We purchased this data from the company Vessel Finder. And then it shows us for every 10 seconds, that's the highest resolution they had, 10 seconds. It shows us the time, the latitude, longitude, the COG, this is course over ground, speed over ground, and then the heading of the boat, relative to the water. This is relative to the land, that's relative to the water. And now here, important is the dimensions of the vessel, about where the GPS antenna is located. So let's pause a minute and look at that. Let's see, file, nope. Well, okay, boat settings, dimensions, and here we put this in. This is this exact data, A, B, C, and D, we get right off of here, which shows where this is. This plus this is 400 meters. That's the length of the vessel. This is the beam, 36 plus 29. So this has it forward up here, right about there. Draft 15.7. And then this has another unique feature, this program. We can go here and assign an image of an actual vessel image of the boat, of the ship here, like that. And that's at 400 meters. And if we need to check that, okay, that's okay. And we can go here, use a ruler tool. If I go down here, say ruler tool, and come up here, I ought to get 400 meters. I do, 400 meters, escape. And if I went here, ruler tool to here, I'm going to get my 59 or, 50. Oh, well, I should zoom this in and do it more carefully, right? That's going to be 59 meters. Okay, that's right. So these things, since we're talking about very close quarters, all this stuff has to be right, and that just confirms that that's right. Okay, so here's the NEMA sentences that we get, these data streaming like this. Now this is every 10 seconds. I think what we can show, or maybe showed in the last video, that sometimes you have to do things make responses maybe even a lot quicker than that. But anyway, then these sentences, these NEMA data is a CSV file, and then we load that CSV file into Excel, and then use the rules for creating NEMA sentences. There is, I'll put a NEMA revealed. If you Google NEMA revealed, it tells you the structure of these sentences, and then we have to create those. This first sentence just says it's a valid GPS signal. Most of the programs want to be sure of that. They want to warn you if your GPS signal is not any good, so you need to have that if you're simulating it. But all the navigation information is basically here. This is the RMC figure, sentence. It's got this is the time, that's the latitude, longitude. This is the 9.7 east. That's really interesting. 9.7 and 9.7. It was the speed and heading were the same. That's interesting. Okay, then here is the the cog and sog, and then here was the heading of the vessel. That's just the way it started out. It's just weird. I never noticed that. Okay, so then that's the data, and then we take that data and then make that into just a file. That file looks like this, and it's just a file of all those sentences. See, every 3 seconds, there's at 007, there's 3 of these. Then 10 seconds later, there's 3 of these, and so forth. So that's the way we make the data, and then you go into the program preferences, NEMA sentences, and here's where you connect to your actual real GPS. But in this case, we're going to say use a file, and we choose that file. And we're going to replay it every 3 seconds. That's 3,000 milliseconds. And we're going to take 3 lines at a time. And we want to show these control sliders, which I'll show in a moment. Okay, so that's the way that you display that then. And so if I then start the NEMA sentence here, so this is then, here, and this will center on the boat, clicking up here. And then then you slide this back and forth to determine how fast you take the data, or if you want to stop and talk about it or think about it, you go there, or you can go a little faster up here. This tells you it's starting right in the beginning. If I go up here, like about here, and then let's say, is it going to jump up there automatically? Yeah, now center on the boat there, and you see it's way up the track. It's about that far up our sentence. So that's the way that process works. And that works very nicely. The other thing you can do is we have this track that we showed in the other program, and so we can go up here. Then once we have the track of where the vessel went, like this is our reenactment, or our study case for teaching the value of cog and sog. Cog and a heading line. We can then we can export that and save it, or we can import it back. Let's say here, wait a minute, ship report evergreen track. Yeah, that's good. And then you see that track comes back in here. And so that's the track of the vessel from the last time we did it. And you put your cursor on here, you can read that vessel was going 41 direction 04, well, should have said 004.1 degrees, and its speed was just put it on there, speed 13.7, direction 004, and so forth. And look, this is always going to go bang smack right through the real location of the GPS. So those tracks have that's just the training tools that you have within this program. And now let's just delete. Yes, okay. And now just a couple quick notes. I'll come back on more on this later. But the way that these ENC charts work, and we have a book on this, which I'll reference. But you can, this is a dredge area here. You can right-click that and then say Vector Chart Elements, and it tells me that's a dredged area, 11 to 25 meters, and so forth. If I go back here, here's a buoy here. This is this very special buoy. This is a current buoy. So if I go here and say Vector Chart Elements, like that, it'll tell me that this is a special purpose buoy. In fact, does it say current? Strong current warning marker. Right, like here, it tells us all of that. And furthermore, this even gives you a little picture of what the buoys look like. But I'll come back. We're going to discuss current in this channel later on. The wind and the current played a big factor in this transit up here. You had very, very strong current going that way, we believe, and we have very strong wind going this way, we believe. And then so we'll show that later. But generally, the way ENC charts work is, and this is set up at the safety contour, this one that's marked, but for any of these buoys, you just just right-click it or anything, and you want to learn what's about the buoy or light, you do it that way. So that's the way you interact with ENCs. We have entire courses on how to use the ENC charts. Another nice thing here is because you can put in, I put that picture in, that didn't come with anything, but you can put in pictures of what that island looks like. It's a very famous island actually in a way. But in other words, the way you do that is you can just, like, let's say you're on this area here and you want to see what that might look like. You would go up here, View, Show in Google Earth, and it's going to home in to exactly the area you were looking at on your real chart right here, and that's like that. Now, for that to work, you obviously need an internet connection, which not all vessels have. Some have. Large ships like this certainly have internet connection, and some yachts do too. But in a year or so, just about a year or so, all these low Earth orbit Wi-Fi, Wi-Fi satellites will be up there, and everybody's going to have Wi-Fi everywhere they go. But that's not quite true right now. But that's a possibility. All right, well, I'll stop there on this background. We have 3 or 4 different pieces of background to add.